Thank you, everyone. I realise I'm up against two very competitive choices in Graham Dumpleton and Graham Cross, so I appreciate your choice to be here today, and I hope I don't disappoint. So just to get a show of hands, who has some experience writing tests, running tests, working with test suites? Not Pytest, just any kind of test suite. Most people, great. And who has experience with Pytest specifically? Excellent. So most of you haven't used Pytest, so that's perfect. And so my aim with this talk is to give you a bit of a whirlwind overview with lots of examples of Pytest in use at my workplace and also in open source projects, and to not really have everybody understand every single line of code that I show, because I'm going to show a lot of code. It's up on GitHub, and I'll have the link at the end, so don't try and scribble down anything you see right now. But the aim is to make you aware of what's possible and give you a little bit of an idea of how to go about it so that you can think about how is that applicable to your projects, and then you can go and look at the source code in more detail later and figure out how to do it for yourself. And so Pytest describes itself as no boilerplate testing, and that's the thing that I really like about it. Your tests can be really succinct. You just write the things in your test that you care about. You're not doing a lot of all your setup and teardown is kind of neatly hidden away, and you don't have to write classes if you don't want to write classes. You can just write functions to have your tests. So you can, if you have an existing library that has a test suite that has doc tests or unit tests, you can run those under Pytest, and you can also write them in what's called the nose style. Nose actually was a fork of Pytest at version 0.8, so I think everything you can do in nose you can do in Pytest. And because you can do what's called kind of natural asserts, so you can just do assert x is whatever rather than assert equal x other thing. So that's quite nice. And so if there was a whole lot of things listed there that didn't really make any sense to you, that's kind of good, because then you won't be bored with what's actually in this talk. So we've been using Pytest for about 18 months at work, and I've really enjoyed it. I've found it really natural to work with, and it makes me feel like I'm an awesome developer because it's just really easy and encouraging to write tests in that style. So the project I work on is called the Graphical Forecast Editor. It's a client-server application that's used by forecasters on their desktop to produce the forecasts. This is the old GUI, which was in TK, so it looks especially early 90s. But there's heaps of, this is just like gridded data, basically, gridded statistics. And people, the forecasters can use that to automatically generate the text that produces forecasts like this that get assembled on the web and look nice. And so it started out in the US, so we inherited a bunch of code from the US. There was a pilot project to try it out in the Victorian office, and then there was funding to roll it out to all the states around Australia. And so that's where I and the people that I work with came on board. So they needed to really ramp up the project. They hired a bunch of us to write new features, and while we were doing that, we discovered that we needed to rewrite a lot of the old features so that they were nicer to work with and nicer to test. And so that's what we've been doing. And so it did actually come with some tests, and I'll talk about that at the end, about how we've evolved them into more sensible tests. And I also wanted to say, if you want to ask questions as we go through, please do, although, as I said, I don't expect everyone to understand every line, but if I seem to have left out something very obvious, just put up your hand and I'll try and address that as we go through. Now, on to Pytest. So one of the things that we mentioned was informative error reporting. So can the people at the back read this okay, or is this too small? If this is too small, you'll probably want to come and sit at the front now, because I have a lot of text that is not a lot bigger than this. Everyone's choosing, no, that's good, come forward, be happy, be able to read. So the native style of traceback, you can get that if you want, but it will rewrite your failing assertions to be a little bit nicer. There's a kind of traceback short option, which I find very succinct and very nice. And there is a longer option which gives you more context of the test, so that when they fail, you don't need to rerun them to figure out exactly what was wrong. You have a lot of information right there to figure out what happened. So it's very extensible. It comes with a lot of plugins, and it also is easy to add plugins. And so this is an example that was actually cribbed from Nose, I think, where in unit test style tests you have things like assert equal x, y, but there's also things like assert almost equal, which is actually quite useful if you're testing things relating to floats. And so this is something you can do to add like assert almost equal back into the Pytest namespace. So at the bottom, the last two lines are an actual test where we're doing py.test.assert almost equal, and we can specify exactly how equal they should be. So it's extensible in the sense that you can make things available in your tests, and then you can also add options so that when you run Pytest from the command line, it can behave in particular ways. So this is something else we did to add a --win PDB option. So typically you run Pytest and you can use -k to select, with a keyword, to select a subset of tests. So you could put just the name of one specific test if you just want to run that test, and then you can add like --win PDB to launch the debugger, which is super, super useful if you really can't figure out why your test is failing or what's going on. It has very flexible options for marking your tests in different ways. The first two that are built in that are very obvious that you're going to need are skip and xfail. So you can say if some conditions are present, this test is not relevant, so just skip it, don't run it. And you typically use decorators to do that, but you can also, in the last example, we've got this py.test.skip, it's kind of programmatic skip. So if you need to have started some of your test up to figure out that actually you can't run, you can do that as well. Gives you a bit more power than just using the decorator. You can set tests to be expected to fail, which is what xfail means, and this is super useful for when you're writing regression tests or demonstration tests for bugs. So before you've written the fix, if you're going to do test-driven development, first you write the test that demonstrates the bug. So you fill out a form and you should get an OK response, but actually you get a 404 or something. So you write the test that and in the test you write, I should get an OK response, and you set it to xfail because it's getting 404 instead of writing the test that you expect to get 404, which you generally don't expect to get. And when you run your tests, if they fail and you put them as xfail, they're marked as xfail, and that's an OK status. If you mark them as xfail and they pass, that's called xpass, which is unexpected pass. And so in the context of that, it's actually like a test failure, which is a little bit confusing. There's also an option to run Pytest with --run xfail, and what that means is run xfail tests as if they were not marked xfail, because your xfail tests are running all the time, like they have to run to check that they did actually fail. And so if you do that, then you just get your tracebacks. Obviously, you don't get those if it actually expects your test to fail. And you can use these markers basically just to add metadata to your test, and we use these a lot just to group related tests over multiple files. If we are working on something and we want to organise our tests in multiple files, but we still want to say that these things are related. And so you can use these marks to, when you're running a selection of tests, just run the tests that have a particular mark by using -m. And we also use these marks to relate our tests to our issues in our bug tracker. So we use the Mantis bug tracker, and we just use like Mantis 1543 to refer to a particular bug. And that's very useful for our testers so that they can see what tests have we written for a particular thing, what is the coverage like. And you can run code coverage with Pytest as well, just with those tests to see have you actually covered all the cases for the pieces of code that you touched when you were writing the fix. And because you can choose to have these as like registered or not, so that you have a limited set, and then if you make a typo, Pytest will tell you it doesn't know about some mark, but we just use them free form and you can kind of make them whatever you want, so that's quite flexible. Now, something that we do quite a lot is parametrized tests. So we have a test where we want to test a function. Maybe it's converting a rounding, for example, where we have some wacky rounding system. And we just want to feed a bunch of different data points into it and say, this is the input, this is what we expect as the output. And we want to have it in a way that is really succinct, so as little boilerplate as possible. There is a Pytest mark parametrized in 2.2, which is the latest version of Pytest. And so for really simple data that you can just explicate like that, you can put it in the decorator and do that. Although I find that's a lot of data to put in a decorator, and if you need to do something a bit more complicated than that, then you're going to need something a bit more powerful than a decorator. And so Pytest has if you put a function called Pytest generate tests in your test file, it will use that to create all the different instances of tests that you tell it to create. So if here, for example, in our code, we've got a is_square function, and then in our test file, we've got this Pytest generate tests, and we've got a def test is_square. So this test is got two arguments, n and expected. And so it's kind of like, well, where is that information coming from? And so Pytest is going to take that information from your generate tests function and feed it into your test. And so if you run Pytest collect only, which just lists the name of all the tests, there'll be 50 tests, 50 versions of this test. And so you can control what information you feed it, what you want the name of the test to be, and you can also, using this approach, you can feed this data into multiple test functions in your file if you were doing that. I find that that's a little bit of a strange approach. So obviously you can only have one Pytest generate tests per file, per module, but you might want to have different parameterizations for different tests, even in the same file. And so we actually have something that was added to our project by one of my workmates, Darius, who I think is hiding up the back. And so this lets us have a generate function per test function. So instead of having the generate tests, which has a bit of boilerplate, it's like, if the test function is called this, feed it this data. We have a convention that we're going to have a function that's called generate foo, and that's going to correspond to test foo. So the generate function is going to feed, it's just going to be the one function that feeds information into the one test function. And so then we don't need to do the magic about have we got the function name right or whatever, and we don't need to do a bit of other metafunc stuff. And so this is really like a nice, very succinct way of specifying generated tests. Something else that you can do with Pytest is monkeypatching. And monkeypatching is like a general term that refers to the awesome ability in Python to change whatever you like on the fly, because everything's an object. So if you have some code that sends emails, probably in your test library, you don't want to send 100 emails just because you have a test that covers that functionality. So you want to patch out or replace the bit that says it's sending an email with something that just sends something into the ether or just attaches something, appends something to a list or something like that. So this is quite common whenever you're doing stuff that needs to touch the OS or touch external servers or libraries, or you don't want to hit some database every time you run a test or that kind of thing. And so monkeypatch, that's kind of the general process of monkeypatching. And you can DIY, where you just literally just replace some attribute or some dictionary item, but you always kind of need to remember to undo what you've done. And that can be annoying and tricky, and so Pytest comes with this monkeypatch plugin that will undo that stuff for you. So we're using this monkeypatch.setAttr. So we're replacing the expand user function on the OS path library, and that's going to undo that when that test is complete for us, so we don't have to worry about side effects with our other tests. As well as setAttr, there's set item for dictionary items and setM for environment variables. And this is our first site of the infamous Funcargs, which the title is all about. So in this test, we've got def test get SSH monkey patch. And so where is this monkey patch, where is it coming from? It's not exactly being fed to the test from a generator like the previous example. It's basically, so that's the Funcarg. That's what one looks like when you write your test. It's a variable that you put into your test and it gets fed into your test, even though in your test file it's not necessarily obvious where it came from. Now, so the thing about monkey patching is that it can have side effects that you don't necessarily want and can end badly. And so Ian Bicking said in a 2008 blog post that monkey patch threatens everything you value about modularity. So use with caution. And so with Funcargs, let's look at an example of writing our own. So with unit test fixtures, people are probably familiar with these terms, where you need to provide some setup data to your test. And so you might put some data in your database, and then at the end of the test you need to take it out again or remove it, restore your database to the state that it was in. And so in this test, right at the bottom, we've got test DB, and they're taking this DB object. And so this information above is what's defining what is that DB object. And so we've got Pytest _Funcarg _DB that takes the request. And so that is the definition for Pytest of what is a Funcarg. And so the information that you need to give it to define a Funcarg is what is the setup, what is the teardown, and what's the scope of it. And so your scope can be function, module, session, and like the setup and teardowns can be very similar to what you are already doing with unit test style tests. And so you can use this Funcarg idea, you can use to express a lot of different things that you might need for your tests. So there's a few libraries that tie Pytest more usefully into other frameworks. So one is Django. It's called Pytest Django. So in these tests, we've got the Funcargs RF, which is a request factory, and we've got another one called admin_client. I'm sure you can guess what that is. And so they're quite similar to things that are available in the Django unit test style of doing things, I believe. And so this just gives you those things as Funcargs. With the Google App Engine, like there's some trivial examples. You can have an anonymous app, a user-registered app, or an administrator app. And with these, you can see how simple it is to actually write these. Like all you're specifying is like 4 pieces of information. But you can have, you could have a test that takes all 3 of these things as different things. So you can mix and match them much more powerfully, I think, because you can have, you don't need to have all your tests that use the anonymous app in one file. They can be spread across all your files, and you can arrange your tests however you want to. So to talk a little bit more about why would you do things in this style, it encourages a style which is the words dependency injection are thrown around a lot at our work, and Martin Fowler talks about this in 2004. And basically the idea is, instead of having a class instantiate the things that it needs, its dependencies, you pass its dependencies to it. And that doesn't sound like an awful lot, and it's something that is often quite natural in Python anyway, but it becomes quite powerful because it makes it a lot easier to test things with mock infrastructure. So if you have a function that is doing something with a database, instead of passing it the string that is the database name and having it connect to the database, you pass it a database that has already been instantiated. And then when you come to test that function, it's super easy to pass it a mock database or a SQLite database or whatever else is appropriate for your testing. And you don't need to actually monkey patch your function to not connect to the real database. And it works really well with test-driven development. So you write your tests first, and in a way, writing the test helps you're designing for testing, because if you're writing the test first, then it is in a way so that you can test that function, and then it's much easier to go to your code and write the code that actually does the thing with the real database or the real spatial data or whatever. So let's look at a few more examples. So this is a real database example from our code, and it's almost certainly not the best way to do database things, but we have a small MySQL database that's connected to our stuff, and this is just a setup function. So in our Funcargs, in our conftest.py, which is where we define our Funcargs, we have a test database, and so that's doing the setup, and the scope for that is session, which is important because we don't want to destroy the database on every test. Then we have the empty DB Funcarg, and so that's just deleting all the data out of the database so that each time it is fresh. And so the scope on that one is function. And so if we are writing a test that needs a database, we're going to use the empty DB Funcarg rather than the test DB Funcarg. But the empty DB obviously requires the test DB to set up. And so basically, we need to say, well, this Funcarg has a dependency on this other Funcarg. And the way that you do that is with this request.getFuncarg value. And so that helps you specify your dependencies in a really straightforward way. And if we needed to, this is also how, if we were doing Monkeypatch and we needed to get access to the Monkeypatch Funcarg, that's what we'd do. Instead of underscore, we'd call it Monkeypatch, and then we'd just use it as if we were in the test. You can also use it to express prerequisites in a way. So this is a Funcarg called libudev. So we try and import it and load some crazy library. And if we can't do that, then we're just going to skip that test. And so this is a really neat way of expressing, this test needs this thing, and if it can't have it, then you can just ignore this test. And so that's just a little bit too complicated for a decorator, but it's kind of perfect for a Funcarg. Now to go back to monkeypatching. So if you need to monkeypatch a couple of things at once, or your monkeypatching is a little bit more involved, then a Funcarg is a good way of bundling up what you're doing and expressing that as a requirement on your test. So this is one that I wrote, which is called no previous warnings. So we don't want to hit some database and get some real data because that's going to screw everything up. And so we've got this monkeypatch equals request.getFuncarg value monkeypatch. And then I'm just doing my regular monkeypatching. I'm not doing any teardown in this because I'm relying on monkeypatch to do its teardown. And the scope for that is function. And so with this, we're not actually returning anything from this function. And so we're not providing an object that you can actually use, but we are doing the test setup in a way that is quite concise. But if you're doing that a lot, it's probably a code smell and maybe it's not a good idea. In Pytest, the author of Pytest works on PyPy, and so he has some stuff so that the PyPy, or maybe not the PyPy, but other tests that he's written will run over all versions of Python. And so using a combination of a Funcarg called AnyPython and generate tests, basically when he's written his test, he just puts AnyPython in as a Funcarg, and then it's automatically going to run that test over whatever versions of Python are installed on the system. So you can imagine that that's going to be super useful if you have kind of your continuous integration set up and you want your test to pass on everything all the time. And yeah, so if that looked super confusing, just think about the benefit from that way, from having your test coverage over 8 different things, and in your test all you've done is add this one Funcarg. So it's a very concise way of expanding your test coverage. Python 2.3 is going to have a slightly different API. So instead of doing the Pytest _Funcarg _, whatever, you're just going to define a function called whatever, or SMTP in this example. Instead of taking a request, it's going to take a text context, but they're kind of similar things as far as I can tell. And instead of having the magic function name that makes it a Funcarg, you decorate it with a Pytest factory, and that's what marks it as a Funcarg. And you put the scope up in the decorator, and you've got this add finalizer instead of a teardown. But basically, you've still got the same elements. You've got the setup, your teardown, and your scope, and so you have all these things here. Now, in addition, these are even more powerful because it has this params, and basically this is parameterizing your Funcarg. So in the previous example where we had any Python, and we were combining that with generate test to do all the different versions of Python. In this, we are just specifying it directly into the Funcarg that, like, there's 2 versions of this Funcarg. And so any tests that use the Funcarg SMTP are going to have 2 generated versions for each of those parameters. So I actually have no minutes to go, so I won't talk about that. But you can look at those slides on SlideShare if you really want to. So now you should have a good idea, or a bit of an idea, of most of the things that I've mentioned here. And so I think one of the real benefits to Pytest is it has very good support for running distributed tests. And if you have a lot of tests, or they take a lot of time to run, that's super useful. And using Funcargs really helps you isolate your test interdependencies and get rid of them. And like you really need to come to grips with that when you are running distributed tests, because they're not running in the same order as they would just on your box. And that's when you really start to find, oh, this has this interdependency I had no idea about, because suddenly they're running in a different order. And so, yeah, Funcargs, I just think, are a really nice way of being able to isolate those interdependencies and tie them down and keep them all together. And I think it will make you feel like a smarter developer once you do it. So if you have questions, the PyDev mailing list is quite good. There's also a testing in Python mailing list. And there's some questions on Stack Overflow. The lead developer, Holger Krekel, is really awesome. He will answer lots of questions, and he wants to develop Stack Overflow as kind of the frequently asked questions. So it's a good idea to ask your questions there. And thanks to the Bureau of Meteorology, so most of the examples that didn't have comments are from our code. And Darius Powell introduced our project to Pytest, which is awesome and has really helped us all figure out how to use it. And if you want to look at the examples in more detail, you can look at that thing on GitHub, which has them all there. And that's all I have. Thank you.
Alrighty. Because it started a minute late, I could probably wrangle half a question if someone has a quick one. Can you have a quick question? Yeah.
Do you know when Pytest 2.3 is due out?
Pytest 2.3?
Yeah.
Yes, so should be mid-September. And so with the new style, all your old ones will still work. So you don't have to convert them. They're still supporting the old API. But if you want, and in some instances, it will be a lot nicer to convert them to the new style. And I think there's some other benefits relating to the cached setup thing, which I didn't really understand, but I'm sure that the new way is better. It always is, right? It is a bit nicer just to use the pytest.factory, and you don't have the magic name, and I think it's a little bit nicer.
Okay, cool. Well, here is some gifts for you. You have a mug and some African Swallow coffee.
Thank you.
Join me again in thanking Brianna.